Hello, my name is Bram Zijlstra. I'm a machine learning engineer at Media Distillery.
Hello, I'm Joanna Krajewska and I'm also a machine learning engineer at Media Distillery.
And at Media Distillery, we build software applications for TV operators using machine learning, for example, computer vision and natural language processing. And today we want to show you whether you can judge a video by its cover. As you might know, machine learning is getting bigger and bigger, and the applications are very widespread. So here you see some examples of computer vision, namely object detection, face recognition, object classification. And while they are all very different, they all have one thing in common, and that is that the ground truth of each is very straightforward, right? So you know whether a person is either person A or B, and whether you're looking at a building or not. And yeah, we want to show you something different that you can do with machine learning today. So I want to give you an idea how pretty an image is. So this is more of a subjective thing to rate. We're going to show you how to do that on a content-based way, which is also fully automated. So we want to show you how we can divide pretty and appealing images from ugly images.
So, can we judge a video by its cover? Well, of course we can, and we do it very often when we use YouTube, Netflix, or any other video on demand service, especially when we are stuck at home for a year and mindlessly scroll and look for something new to watch. That set cover of the video is its thumbnail. So let's take a second to establish why it's important to have a good thumbnail and what makes them good. So first and foremost, it's important for us users because it saves us a lot of time. We should be able to say what the video is about before even clicking on it. It also helps us remember which episodes we've seen already and which not. And for video providers, it's important because if the platform has a good user experience, the probability that we'll stay longer or even come back to it is higher. Okay, so what makes a good video thumbnail? As with all things user experience related, it's easier to say what makes a bad thumbnail. So the bad thumbnail is anything that's too dark, too bright, or has blur, any other artifacts, people with weird facial expressions, or even people with faces cut in half. Bad thumbnails also contain spoilers or are just clickbaits. So let's now have a closer look how the big guys are doing this. So YouTube and Netflix. So YouTube has to process lots of new videos every day, and they have a very limited time to do that, and also very limited information about the videos itself. So they don't do it by hand for most of the videos, but they have a deep learning model which is doing it for them. It simply splits video into individual frames, rates them, and chooses the frame with the highest rating. But at the same time, for some of the videos, the thumbnails are created by hand by the content creators. So if you are a professional YouTuber, you probably take a photo yourself, add some graphics, and upload this as a thumbnail. It looks way more professional and stand out in the crowd of other thumbnails. So YouTube also uses those graphics to feed them back into their neural network and make it better. Netflix has a different approach because they have a different business model. They don't have to process as many videos every day. They have more time to create the thumbnails and more information about the show to make it representative. So what they do for their biggest titles, they don't use frames from the videos, but instead they use stills, which are professionals' photos taken to promote the show or a movie. So they take them and add some graphics to create a thumbnail. Their key selling point is personalization, and they also personalize thumbnails. How it works is based on your previous choices, the previous thumbnails you clicked on, and the content you watch the most often. They are generating new thumbnails which have the highest probability that you will click on them as well. So the romance fan will see different thumbnail than the comedy fan. It actually caused them some problems in the past when people realized they were generating thumbs with people of color in them to some of their users, even though those characters didn't have a big part in the show. Quite the opposite, actually.
All right, so now that we have shown you how companies like Netflix and YouTube do it, let's take a look at how we have implemented our solution. So we have a little bit of different problems than the other companies that we mentioned before, because first of all, we don't have any user data. We analyze only on the content and we provide the images to our customers, but we have no feedback loop there. So as a result, we have no way of checking whether one image is more successful than the other. Second of all, we don't have stills from videos. We only analyze 1 frame per second. As a result, the quality of the video of the images is less good. There's fewer techniques you can use, for example, in detecting motion blur and interlacing artifacts. Thirdly, we have no human in the loop. The amount of images that we have to process is just way too much for us to have a human in the loop to correct the images. We have 24/7 data processing in near real time. So that means that our servers have to be fast as well to keep up with the load of analyzing a program every 20 minutes basically. And we have very limited metadata. So unlike, for example, Netflix that we talked about before, we have not really an idea what a program is about. We know the program title, we have the images, and we know a very brief description, but sometimes that's not even correct. So here you can see an example of how, for a lot of TV operators, their catalog looks like. So you see a pretty popular show like Graham Norton, and they have the same stock photo for each image. It doesn't really look nice, and this is how we implement it. So here you can see that every episode has their own guest, which on the UX level, it just looks much prettier. But also you have a better idea who is in each episode. So it is also easier to navigate. We already talked a bit about some of the challenges, but now we're going to talk about each problem that we faced in the project. And the first one is maybe a bit surprising, but that's really about how can we know which frame is actually belonging to a program. And it's maybe a bit confusing for someone who doesn't really know the domain. But TV operators don't actually know when a program starts. So they get the TV guides from another company, and they provide an estimation of when a program starts. So for example, you can see Friends is starting at 2:35 or 2:30. But most of these programs actually start a little bit earlier or a little bit later. And if we don't know the exact start time, we might give an image from one show and give it to a different show. And as a result, the UX is very confusing because, for example, in the Graham Norton example, you could see suddenly an image from a Friends episode. Furthermore, advertisements is also a problem because if we don't filter those, they tend to be rated very highly because they are very bright in colors and they look pretty usually. So if we don't filter out advertisements, they will just show up in the UX of a viewer, and that's of course very annoying. How we do it? This is basically the EPG, how it looks like in your own EPG. Program starts from 10 to 11, for example, whereas in real life it starts maybe 5 minutes later. There's an ad break around halfway that takes 7 minutes, and then there is a continuation of program A. So we basically need to define these ad breaks and also when the program ends. And we do that by analyzing the raw data of a TV stream. So we get frames coming in, and we are looking for certain visual cues that help us detecting a start time, also the start of an advertisement, the end of an advertisement, and the end of a program. So let's take a look at some of these cues that we are looking for. So for example, one of them is a promo logo. These usually happens between a program. So when we see one of those, we know that the new program is coming up. Other ones are parental guides. They usually show up at the start of a program. So when we see that appearing, we know that the program is about to start. And we also have channel bumpers. These are also used between programs.
Okay, so we know which frames belong to the program. So now we can start selecting which are the best candidates to become thumbnails. We do that by giving a different ratings based on predefined criteria. Two first criterias are, is the frame pretty enough? That's pretty quite self-explanatory. And does the frame has good quality? Because we operate on videos, we have to deal with a lot of motion blur on frames and other artifacts. So we needed a model that will tell us that the frame contained those. Those two problems sounded like something which was already solved by people smarter than us. So we asked the internet and found the exact solution we were looking for. It works similar as the deep learning model used by YouTube. It takes an image and just returns a rating for it. We really liked this one because it had two steps. The first step was technical assessment. So it rated an image based on how good quality of the frame is. And the second one was aesthetics. So it's a subjective rating how pretty the model thinks the image is. And this model was trained on images of landscapes, buildings, people. So it's a completely different domain of data that we use. So at first, we didn't get good results. Here you can see that on the left, not so good frame got almost the same rating as the frame on the right, which is much better. So we needed to do something about it. And what we did, we applied transfer learning. So if you don't know, transfer learning is this very cool thing in machine learning where you can find a solution to a similar problem that you are having and just reuse it. So in traditional machine learning, to train a model, you need to have a bunch of data annotated and train it. But in transfer learning, you can find something similar. So for example, if you want to train a model that is classifying flowers, you can find a model which is doing some sort of other image recognition task, for example, classifying trees, and then just retrain the last layer. It's great because you need less data to achieve great results, and also training time is much quicker. It's quite similar to how people are learning languages, if you think about it. Basic languages, but also programming languages in more specific. So the first language, when you learn it, is quite complex because you have to learn a lot of concepts like what is programming, what is a variable, how do I use for loops or if conditions. But if you want to learn another language, it's easier because you have all of those information already. So you just have to learn a new syntax and other language specific things. So we applied transfer learning to aesthetics model, and we got much better results. Okay, so we can rate how good the frames look, but it's not all there is to them. Because we operate on frames from TV streams, we receive a lot of additional things on the frames that we have to get rid of, like logos, subtitles, overlays, and so on. One of the requests from our customers was to give thumbnails propositions without those artifacts on them because they want to reuse those thumbnails on their different platforms, and it just doesn't look good. First, we wanted to discard those frames with a lot of noise on them, but it quickly turned out that we would have to discard most of the frames that we have. So we decided to detect those artifacts and crop them out instead. So to achieve this, we needed to build some additional models to detect those artifacts. So logo detector and text detector. So cropping out text is fairly easy because it's usually placed at the bottom of the frame. So we can just crop it out. But for logos, it's a bit more complex because usually logo is like in the right corner of the frame, so we can crop either left or top part of the frame. So we needed to decide which crop would be better. And it quickly turned out that we also have to take into consideration how faces are placed in the frame, because we didn't want to crop in the middle of the frame or like crop out the top of the head, like here on the right example. So we needed to build face detector and take this into account when we choose the crop. Here is a good example how this works. So we have two possibilities to crop out left side of the frame, and this would produce a bigger crop. And on the right, you can see how it would look like if we wanted to crop out top part of the frame with the logo. We would crop out heads in the middle or like heads in total. So the crop would be actually really small.
Okay, so now that we have shown you how we can find good looking images, we also want to have an idea of the context of a program. Because, yeah, you can see a good image, but if it's not really representative of the program, it's not really a nice one in your user experience, right? You want to see an image and have an idea what it is about. It gives you a better impression of the content. And we do that by looking how an image relates to the rest of the content. We tried several techniques for this, but the one we found out was working best was by finding main actors. These are all very pretty images from one program, but since they're not main actors, you don't really have an idea what this program is about. They're all from Mr. Robot. So we want to have images more like these, where you actually see some of the lead characters. It's especially when you see a lot of these images, it looks better to have an idea of who the main actors are. So the way we do that is we detect the faces of people in each frame, and then we try to distinguish the main actors, or for example, in a talk show, the main interviewee, and distinguish them from the extras or the people in the crowd. It doesn't really scale for us to label all actors in every show because we operate in several countries. So we investigated an unsupervised technique, and the results were actually pretty good. So the way we did it is we use face recognition to get descriptors out of from each face. So a descriptor is a numerical representation of a face, and the idea behind these descriptors are is the closer they are together, the more like the more they look like each other. So two images of one person have descriptors that are very near each other, and two descriptors of different people, they are very separate from each other. So we clustered all these images using dbScan, which is a density-based clustering algorithm. And the advantage of using this is over, for example, something like k-means, is that you don't have to know how many clusters you need. This is, of course, very useful for face recognition, because on a TV show, you don't know beforehand how many actors there are in a program. Or when it's about live television, you don't have an idea how many people are interviewed. It also handles outliers really well. So for example, this is a simple representation where we see three clusters, and we see some that are a little bit too far out of each cluster. These are seen as outliers. So that can be, for example, one shot of an extra, or maybe sometimes a misdetection. And then we pick the biggest clusters on the assumption that these are the lead actors. So in this case, it would be the red cluster. We see this person occurring most often. So we kind of assume that this is the lead actor. And if we apply that to the previous parts where we showed how to find a good looking image, we can find good looking images that are also more representative of the content. So here again is an example of the Graham Norton show, where we actually see the people from on the seat, and not, for example, a person that's interviewed very shortly during the program. But we also have to apply some business rules. For example, sometimes you don't always want to pick number one. In this case, that would be Graham Norton. So, because if we would always show an image of Graham Norton, then we are kind of back to square one that we showed at the start. All right, so on to the next problem, which is speed. We showed already that we do a lot of analysis. So just to recap it quickly, we use face detection to detect all these persons that occur in the video. We use text detection, we detect logos, then we use some cropping techniques to figure out the best way to crop an image, and then we rate it. And then for each program, we find the top K, and the top K depends a bit on the customer requirements. Some customers still want to have an editorial team in the loop, so then we propose several images that they can pick, and sometimes if it's fully automated, we just show one image. But all these components together made the service too slow. It took roughly 0.7 seconds for each image, and if you would have to use that for a lot of different channels, it's just way too slow for to get a lot of analysis at the same time. So we needed to figure a way out to make it faster. yeah, like we said, we only analyze 1 frame per second, which is already is helping a lot. And we use GPUs for parts that are too slow, especially for the machine learning models. They really benefit from using GPUs. But still, there was not enough to scale up for several customers. So what we did is we used a new technique where we measured twice and cut once, basically. And how that looks like is I can show you in the following example. What we noticed was that the rating service that we made was actually really fast, and it has a very good estimation about how the final product would look like. So what we did was we used that rating service to give an initial rating, even if we have all these artifacts still on it and haven't analyzed the faces and etc. And we use that to find out the best images as sort of an initial proposal. And then we use a full analysis at the end. We found out that the correlation was very high between the full image rating and the cropped post-processed image. So we could use that to optimize much faster. So the process that we moved to was a little bit different than I showed initially. So we first rate in full image, which takes us roughly 0.03 seconds. So it's way faster than the 0.7 seconds. And then we store the best X images. And the X, that really depends a bit on how good the correlation is. But it's something in the order between 20 and 50 images. So if you see a program, for example, that's 20 minutes long, we have 60 images coming in every minute. So you reduce a lot of calculations, which makes the service much faster. And then we do the entire analysis. So we detect the faces, we detect subtitles and other text, we detect channel logos and other unwanted logos, and some other stuff. So, for example, we try to detect some coloring differences, the closed eyes, of course. And in the end, we crop. And after the crop, we do another rating to get a rating on the actual image that we want to propose.
And the last problem is operations. So right now we have 5 machine learning models that we have to maintain, and they're in production. But in the development phase, we have 4 additional ones. So it's a lot of training and maintaining to do. So how do we keep our models healthy and our heads healthy as well? So we introduced this almost automatic pipeline. We have a fun tool and easy to use. We created this in Prodigy, and we gave it to our colleagues. And then in this tool, they can provide feedback for our episodic images. And at the same time, they annotate data, which is versioned using DVC. We created automatic training pipelines on Kubeflow, which we can just trigger with one push of a button, and it retrains our models. For deployment, we use Jenkins pipelines, and we use Docker and Kubernetes. And for monitoring, we have Kibana and Prometheus and Grafana, which are staples in the machine learning world. But we also have our own platform on Media Distillery, which makes it easy for us to see episodic images propositions for each program and check if they are correct.
So here's a demonstration of the own dashboard that we implemented. So as you can see, here are all the programs of one TV channel, and everywhere we show the best looking image. And if you click on each program, we see several of the propositions that we made. And for each program, you can quickly go through them. And if there's one image, for example, this one that we don't really like, our product team can easily replace it so that the customer gets an update and the image gets replaced. So this is basically a tool that we developed because it helps us correcting the less pretty looking images quickly. We also send these images to our own data set so we can retrain it and improve the product continuously. All right, some closing thoughts. I hope by now we have showed you that you can actually judge a video by its cover. I think we showed that this project had a lot of interesting challenges. So first of all, it was a subjective problem. It's really difficult to quantify how pretty something is. And yeah, we were also showing how we had some unique TV operator specific problems that made it very interesting to work on. We couldn't really copy the same methods that bigger vendors did. And it used a lot of different techniques. So it had several deep learning applications. We had to use transfer learning because, yeah, otherwise we would have to label too much data. We use clustering algorithms and yeah, several other ways of classifying and localization. Yeah, so I hope we convince you that. Thank you very much for your attention. If you want to have more information, you can always visit our website of mediadistillery.com. And if you have any questions, let us know. Thank you very much.